Section 7.2, we're interested in determining area and perimeter for more complicated shapes we notice that we're going to make use of various basic tools. We notice that we should recall area of a rectangle is length times width. Area of a triangle is equal to 1/2 times the base times the height. And area of a circle is equal to pi times the radius squared. And so, oddly enough, we can use these three basics, and then what we already learned in section 7.1 about the area of a regular polygon, to create areas of much more complicated figures. So we notice that, for instance, if we were going to look at a square with a half circle on top of it, we notice that the area of this shape is going to be given by, if we just call this space 4 centimeters, we know that the area is going to be the area of the square plus the area of the half circle. Which we know is going to wind up being 4 centimeters times 4 centimeters plus 1/2 times pi times 4 centimeters. We have to be careful. The radius, you notice that the diameter of the half circle is 4 centimeters. The radius is going to be 2 centimeters. So you have to be very careful about that. So we're going to get 1/2 times pi times 2 centimeters squared. And so we get 16 square centimeters. Plus, that'll end up being 2 times 2 is 4. 1/2 of 4 is 2. Plus 2 pi square centimeters. 2 pi is going to be approximately 6.28. And so we'll get approximately 22.28 square centimeters. And so pretty much any of these shapes can be generated by just breaking things up. So just like we broke up the regular polygons into triangles, we can break up these more complicated shapes into triangles, rectangles, and parts of circles. So an interesting aspect of that is we notice that if we wanted to have a circle with a square cut out of it, so this is called a square inscribed inside of a circle, we might want to know what's the area of the shaded region. And we would need to know what the radius of the circle is. So we'll say this circle is going to be of radius 12 centimeters. So what would we need to know? To determine the area, to determine area of shaded region, instead of adding, now we're going to subtract. We need to know the area of the square. So how can we do that? Once again, we're back to trigonometry. We notice that the square, we said the circle has a radius of 12. So now we notice that we're looking at that square has a diagonal of 24 centimeters. We also know that that triangle formed by the diagonal has an angle of 45 degrees. And because it's a square, we know it's a right triangle. So now we know the height of that square. We know that, once again, actually when sine of 45 has to equal the height of the square divided by 24 centimeters. And so the height of the square has to be 24 centimeters times, we know sine of 45 is radical 2 divided by 2. And so the height of that square is going to be 12 radical 2 centimeters. But this is actually kind of convenient. We don't even have to make an approximation because we now know that the area of the square is going to be 12 radical 2 centimeters squared, which is going to wind up being 288 square centimeters. And so we know the area of the shaded region is the area of the circle minus the area of the square. And so we know we're going to have pi times 12 centimeters squared minus the 288 square centimeters that we already got. And so we know that's going to be pi times 144 gives us approximately 452 square centimeters minus 208 square centimeters. And so that shade region is going to be 164 square centimeters. And so again, quite often we're either going to use subtraction or addition to get the area of more complicated shapes. So let's look at just one more of these just to get an idea for this. We notice that if we had, let's consider a triangle with squares. So we'll have a regular triangle with squares attached to each side. So we'll say that the triangle has side lengths of 6 meters. And so that means that our total shape is something like this. So we have a triangle with a square attached to each side. And we know that we're going to get, the squares are easy, the triangle will be a little bit trickier. But we've actually kind of seen this already. We know that the triangle has interior angles of 60 degrees. And so we can see that we're going to get, we cut it in half. Interior angles are 60. We don't know, well, we actually, yeah, that's right. So we know that the side lengths are 6. And we now know, we have a couple ways of doing this. The most straightforward from the viewpoint of trigonometry is that tangent of 60 is equal to height divided by 3 meters. We then get radical 3 equals h divided by 3 meters. And so we know that the height is 3 radical 3 meters. And so you know that the area of the triangle is equal to 1/2 times the base times the height. And so we end up getting 9 radical 3 square meters. And so we notice that the total area is just going to be 3 times the area of a square plus the area of the triangle and so we end up getting 3 times 36 square meters plus 9 radical 3 square meters so that's going to give us 90 and 18 is 108 square meters. Actually, I'll make this approximate. We know 9 radical 3 is going to be 9 radical 3 gives us, call it 15.6 square centimeters. And so we end up getting 123.6 square centimeters.